Graphing a rational function is a multi-step process, and we want to make sure and identify all the important features of the rational function. That's going to include any asymptotes as well as any intercepts, and then once we plot that information, we can then use what we have to determine what else we might need. Any other points that we might need, we can go ahead and just plug in certain values for x. So let's start off by finding our asymptotes. There's nothing that can be factored on the top or bottom, so this is already in lowest terms. So we can find our vertical asymptotes by setting the denominator equal to 0. But if I try to solve that, that gives me x squared equals negative 2. I subtract 2 from both sides there. Taking that square root of both sides, I would get x equals plus or minus the square root of negative 2. So since that's the square root of a negative, that's not a real number. So there are no vertical asymptotes for this function. A horizontal asymptote depends on the degrees of the top and bottom. The degree of the top is 4, and the degree of the bottom is 2. Since the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. Okay, so let's go ahead and look for some intercepts. So a y-intercept is always the easiest one to find. It's going to be what we get when we plug in a 0 for x. And so that gives us 0 over 2, which is 0. So we get the point 0, 0. And any x-intercepts would be found by setting the top equal to 0. Because in order for a fraction to be equal to 0, the numerator would have to be 0. It doesn't matter what the denominator is. 0 divided by anything is 0. And if the denominator is 0, then it's actually undefined. Now essentially, to solve this equation, we're taking the fourth root of both sides. Now the fourth root of 0 is just 0. So our x-intercept, our only x-intercept, is also the point 0, 0 that we already have plotted. And so we don't have a whole lot there on our graph after looking at the asymptotes and the intercepts. So to get an accurate picture of what's going on, we just need to start plugging in some other numbers for x. So we'll set some things up here in a table, and we'll plug in some things like maybe negative 2, negative 1. We already know what happens when we plug in a 0 for x, so let's go ahead with a 1 and a 2. So if that ends up not being enough, we can always plug more things in, but let's go ahead and plug these in and see what we get. So negative 2 to the 4th power is positive 16. Negative 2 squared is positive 4. 4 plus 2 is 6 there, so we have 16 over 6, or 8 over 3. Plugging a negative 1 in there gives us a positive 1 over 3. And a 1 in there is going to give us 1/3, and a 2 is going to give us 8 over 3. So if we plot these, negative 2, 8/3 is 2 and 2/3. And then negative 1, 1/3. 1, 1/3, 2, 2 and 2/3. So if it's still unclear as to how to complete the rest of the graph, we may go ahead and plug in a 3, negative 3. And each of those is going to give us 81 over 11, which is a little more than 7. So negative 3, and we're above the 7 there, and 3, and we're up above there. And by plotting those points, we see this basically U shape start to emerge there. So we'll go ahead and fill in the rest of our graph. So there's our graph of this rational function.